As an introduction, it's pretty important to say, but I'm sure that you're all aware of this fact, but I'd like to stress this out, that the new buildings represent just a small portion of buildings, and this chart shows that every year only 1.5% of new buildings are added to the building stock. So the most improvements of building could be done on existing buildings. It's pretty clear. So, and the questions regarding sustainability of buildings, I'm not dealing only with, let's say, heat demand or ventilation system. I'm interested in sustainability as a whole. And the questions that I asked myself, that we ask ourselves in our department is it better to refurbish the old building or demolish it and construct a new one? Is it better? Is it more sustainable? And it has a lot of aspects in these questions are inside and covered. So we would like to find out the answer. Another question was, what is the influence of buildings' operation life to its overall environmental sustainability? What's the influence of if we have a building that has been standing for 200 years? Is it more sustainable than a new, perfectly designed wooden building with half a meter insulation? Is it better? Is it not? Is it more sustainable? Well, the question is pending. And last but not least, what is the influence rate of particular buildings' life cycle stages? Because building life cycle could be divided into several stages. Let's say the production process of the building materials, then there is the transport of the materials, construction, operation stage, which takes the longest time, then demolition, and then again closing of the cycle. And what's the proportion? Which stage has the most and the biggest influence on the sustainability? Yeah. To find answers to these questions, we are using, and there are several Multicriterion assessment methods that are being used all around the world. And in the Czech Republic, we are developing our own sustainable tools. All of these tools are based on these triple pillar basements: environment, society, and economy. These are the three basic pillars of sustainability. As you might know, there are several multi-criterion assessment methods like LEED, this is an American one, BREEAM, British one, CASB, it's a Japanese one. And in the Czech Republic, we are following our regulations and following our needs, so we are developing our own sustainable tool for buildings. And then there is another method that could say if the building is sustainable, and we are able to say what life cycle stage has the most impact, and it's called life cycle assessment. Life cycle assessment as itself, it's really at its beginning, and there's a lot of development and research being done. We know a lot of life cycle assessment of particular products, but life cycle assessment of buildings, there are not a lot of these analyses in the world, and also the regulation of this and how it should be done. The life cycle assessment of building was issued last year. Just briefly about the methods that are being used around the world. LEED and BREEAM both have their own schemes for existing buildings. I would say that both of these schemes are more focused on maintenance and maintenance assessment tools, and they say they make an analysis of an existing building, and they say that you can do that and this to improve the building, improve its performance. but it's not holistic enough from our point of view. These are more facility management tools than multi-criterion tools. Yeah, and especially they do not take into account cultural historical value, which is one of the crucial things that influence the possibility of refurbishment. Let's say a few words about SB2CZ. It's being developed at our Department of Building Structures. There are several schemes for residential houses, office buildings, and also single-family houses. We are using it, we've been using it for 3-4 years already. It's also based on these 3 pillars, and we assess environment criteria, social criteria, and economic criteria. These are the weights that have these groups of criteria within the whole assessment. The result is actually one number that aggregates all the criteria and say that if it's good or bad. Let's just briefly say something about the environmental criteria. We want to assess the environmental quality, and it comprises of like more than 10 criteria, such as acidification potential, global warming potential connected to the CO2 emissions, consumption of primary energy, etc. In the social group, we assess the heat comfort, how the building acts towards the user, if it's comfortable or not. Acoustic comfort, flexibility of use, and healthy materials are also involved, and several other criteria. In the economy field, we follow this management process of design and the running of the building. Precise documentation is also important, and facility management as well. It's crucial, actually. If we talk about location, the location stands a little bit aside because it's not covered, aggregated into the resulting number, because the location is nothing that can be actually influenced. Location is just set, but we can say if it's good or bad. But the building itself cannot do anything with the location. Yeah, this is just an overview of the criteria. It's more than 30 criteria within these 3 main groups, and in each criteria there's a benchmark setup how you can improve and how you should act to get a better result. If you are in the early stage of design process of a building, you can use these criteria or SB2CZ as a whole, as a guideline, you know, to get the best result, to get the best building you desire. This is the scaling. It moves from 0 to 10. The best buildings are marked from 8 till 10 points, and it's all aggregated at the end to one number. And if you are the best, you get the golden or yellow leaf. All right, and this is the certificate for a building. Yeah, this one got the silver leaf. All right, and if we move from new buildings, because it's pretty easy to influence the design of a new building. You can do whatever you want, actually. But it's quite different with the existing buildings. And the question is it possible to assess existing buildings with the same approach as new buildings? Well, let's phrase it in this way. We can actually divide existing buildings, according to many criteria. We can put it in many groups, but according to age, structural type, typology, there are many. But the most and the crucial point is the cultural historical value. It influences the quality the most, because within the new buildings we are not able to recognize cultural historical value. This value is added to a building within a certain amount of time. It's connected to this development of society and its, let's say, memory. So sustainability of society is involved. But within the new buildings, we are not able to recognize that. Yeah, and with this cultural historical value, this value shouldn't be, according to our opinion, shouldn't be influenced by the renovation. If so, it should be even raised, but not threatened by the renovation. And if we put it in another way, these are two residential buildings. Both are residential, in both are people living, but the distinction is pretty clear. I don't want to expand on this more. But what's the difference? The difference is that in this case, we want to protect the sustainability of culture. That's another part of sustainability that is not involved when we assess a new building. So here we assess sustainability of environment and stuff that influences the internal comfort, and as I talked about the three pillars. But sustainability of cultures emerges here. So the categories of buildings, Jan already talked about it a little bit before. We can recognize, let's say, 4 groups. A, buildings without recognized cultural historical value. These buildings can be even demolished if we assess them as a bad and reconstruction is not providing us any good solution. Then there are buildings culturally valuable but not listed, not protected. This is a tricky part. Then there could be buildings in a reservation or zone or architectural monuments. If we imagine this as a group, there are existing buildings with cultural historical value. Within this group there are protected monuments and listed buildings. And as mentioned before, there are more than 40,000 of these objects in the Czech Republic. Principles of RESB tool are pretty simple, and they are that we presume that cultural legacy is an inseparable part of sustainability. You cannot take it apart from sustainability. Then implementation of this quality into complex multi-criterion assessment of buildings in RESB tool CZ is necessary if we want to assess it properly, the existing buildings. And then there's a need of possible mutual comparability between existing and new buildings. Yes, this is the comparability, and what does it mean if I say the comparability? In both cases, the cultural historical value is different, but our aim is, if we do the best we can, then both buildings should get the best marks. It's pretty clear. Let's say if we do the best available technology renovation here and here, it should be priced with the best golden leaf. Yeah. Yeah. And another point is also if the building does not represent any cultural historical value, and we are planning to do refurbishment, but the refurbishment is at the very beginning, leading to a dead end, then also it provides us this potential result that it's better to demolish this building and build a new one. This possibility should be involved in this assessment. Again, we can imagine this on this simple graph. With this building, let's imagine a complex quality of a building on this scale. With this building at the beginning, with the renovation process, we can do whatever we want. Even at the end, it could be like complete demolition. But best available technology result. But if we take this building, it is prohibited to demolish it, and the possibilities of changing conditions of these buildings are limited. And so that's the point where cultural historical quality emerges in this field. So if we transform this attitude, this approach, into a certain benchmark setup, let's say this is a benchmark setup for a criteria in environmental group. This is the indicator. What building is at this level, then it gets 8 or 6 point something points. If we look at the building with cultural historical value, its performance is really poor, let's say here. And if we do the best we can, it didn't even move over the 0 value. So what should we do with that? We just define the improvement potential. And improvement potential allows us to adjust this benchmarking process. And that's how we implement the cultural historical value in the assessment. We are not actually assessing this building is better than the other building. No, we are not. We don't want to do this because then we would it would be confusing. So then we make another benchmark setup, renovation moves here, then it gets some points. Yeah, RESB tool CZ approach. But if the building doesn't have any cultural historical value, then this improvement potential approach is not eligible. You cannot use that if the building doesn't have any cultural historical value. So we use the same setup as for new buildings. And the situation could be the same. Existing building without value is here. If we do whatever we can, we move here, then it gets 0. And then the reasonable result is that it's even better maybe to demolish it and build a new building. All right, there were several case studies, and this is the way or the scheme how we want to do the assessment. Then first we have to assess the cultural historical quality, define the best available technology improvement, set up the benchmarks, and then assess the building. It's pretty clear. And then this improvement potential influence only several criteria. And these criteria are most of all in the group of environmental criteria and are connected to the envelope and to the quality of external walls, windows, etc., as my speakers before mentioned. And also user comfort is influenced by this improvement potential approach. In economics and management, we use the same setup as for new buildings. There's no need to change that. All right, to the case studies, we have made several case studies. These are some of them. First of them is a two-family house without cultural historical significance. The second one is Maitreya. Jan already talked about it. And Molako, this is experimental housing from the 60s. It's an architectural monument. It was experimental house. This is the original state. The building was, the performance, heat performance was improved. PV panels were installed on the roof. Yeah, these are the parameters. I'm not sure if it's necessary to expand more on that. The improvement of heat consumption or energy consumption is clear. All right, to the other case study, it's Maitreya. Again, there were windows changed, internal insulation was installed, Ofatex from reed. And then Maitreya experimental housing. This aluminum facade is protected. It was built in 1965. It was the experimental housing presented in Montreal Expo by our famous actor. And this is the result. And these are the results if we use the setup of assessment of the same as for new buildings. And the quality of these buildings within these criteria that are influenced by the improvement potential is pretty poor. In this case, it doesn't make, it says that we can interpret these results, that this building, comparing to quality of newly built building is really poor. But in this case, we should involve this improvement potential because cultural historical quality has been recognized there, and we should take into account this. So, and again, improvement potential application in this case. And if we use this approach in ResB2CZ, then the results change really rapidly, and you can see that we assessed somehow the cultural historical value. We put the importance of preserving this building into the assessment. Yeah. And again, how it's done, we have to determine best available technology and determine the zero value level. How much time do I have? Okay. The last part, I'd like to expand a little bit about life cycle assessment. Life cycle assessment was defined for buildings by a new European norm. And within our team, at our department, we want to find the difference between simplified and complex LCA analysis, because SB2CZ, LEED, BREEAM, they use simplified LCA analysis. That means that it doesn't cover the necessity of refurbishment of certain material. It doesn't cover transportation. It doesn't cover, you know, the potential lifespan that could be influenced by the real technical state or this moral lifespan. So we want to find the answer by making a complex LCA analysis on a case study that we will model the whole life cycle. It's going to be a really robust model of life cycle of a building. And we'd like to find the answers to these questions. And then we want to adjust SB2 according to the results. Yeah, again, this graph, we want to find these proportions. Yeah, what's the main, which stage has the biggest impact on life cycle? If we look at the norm and how much work it comprises, it's going to be a lot of modeling and creating a lot of scenarios. In the rows, we can see parts of the buildings like foundations, lighting system, etc. And here are the modules of a building, like product stage of certain materials. We can get these data that will tell us about their environmental quality impact from EPDs. Then there's a construction process. U stage comprises using, renovation, maintenance, and for each of these rows, we have to make a scenario that will tell us how we deal with this part within renovation after 20 years, and it's connected to several, let's say, inputs, and it's going to be a massive model comprising over 200 scenarios, and hopefully it will give us the answer to the questions we ask ourselves. The most tricky parts are like what's the service life, because the service life of a building is influenced by moral service life and technical service life. Are we even able to define this? Are we wizards? Can we say that the building will last only 30 years or 300 years? We want to make this sensitivity analysis about how the service life influences the whole impact, and I'm getting back to that question from the very beginning. Is a building with 200 years old structure more sustainable than a new one? Then we can also change the use of the building and how it influences the life cycle. That's another tricky part. Social and urban changes, we are not able to predict them. Technological process in transport and all the progress in science. And also we have insufficient data on environmental performance of materials. So these are the questions that we have to face, and it's going to be a really tricky part. And climate changes, we can predict them, but not accurately enough. So the result of our thinking recently is that the LCA should be, and it's pretty clear, made only with known data and clear background. And as I see it, that it's possible to look at building sector as a one entity and assess its impact and environment at a certain point of view. The predictions are if you get into predictions, you lose your credibility and accuracy. Yeah, this is just a model as I see the existing buildings and the building sector. It's all one group, and we should assess this as a one group. And again, we are not able to predict the future of building sector, so we should focus on what we have now and analyze it into really thorough detail. And for the end, this is an example how good we are in predicting the future. This is an archigram concept from Ron Heron, 1964. These walking cities, it was his picture of walking cities. The people live in these small cells, and this huge construction walks around the world and exploit the resources and moves from land to land and you know, get the resources for its living. So I don't think we're heading this way. So that's why we would like to avoid predicting the future. Thank you very much for your attention.